Okay, I wanted to show how the game com's coming along. Got my handy dandy oscilloscope here. You can see that's the actual sound waveform coming off the actual system on chip. So how it works through is you got your signal comes in over here. This cap here gets rid of the DC, there's a DC offset. You can see how it's going off the top of the screen there. This cap cuts down the DC offset, comes into this potentiometer. This is the volume control. And you can see if I turn the volume down, see how small their signal gets. So the signal comes through that potentiometer off the wiping arm. I think that might be part of the problem. It comes off the wiping arm, comes in on the non-inverting input here on the oscilloscope. On the op amp. Pin 3 is always in non-inverting. You got no connect. You have like a null connection, inverting, non-inverting input, and then on the other side, it's hard to get at. The amplified output's over on the. You see, it's off the top of the screen. It's actually really hard to see. I'll show you on here. Pop the screen off real quick. Didn't like that? Okay. So, there's some magic here. Let's go. This is the microscope what I'm talking about here. So the signal actually comes in. I'll get something pointy to show you. Signal comes in on. So the signal chain is you come off of. There's a simple transistor on the other side of the board, and then you come in here. This capacitor here, the signal comes on this trace here, along this chain here. Comes in from the processor, which is this line over here. Comes in. This capacitor here gets rid of the DC offset. It's about looks like there's a 5 volt or a couple volt DC offset, so it gets rid of the DC offset. So it turns to pure AC, and it hits this leg of the potentiometer, and there's your center leg here. And this center leg, this is just going to the ground. So the center leg here goes over to. Start up here in the corner. 1, 2, 3. That's your non-inverting input on this op amp, and then your output is pin 6 over here. That pin 6 runs through this cap, and this cap. Oh, sorry, it doesn't run through that cap. Runs through this 220 microfarad cap, and then goes out to the speaker. And there's a set of traces that run along the back of the board, which actually go over to the headphone jack. So for this particular game com, I'm thinking what it is this potentiometer, even when it's turned all the way over, still it's a 10K potentiometer, still a 1K. It doesn't go all the way. How you set the gain on the amplifier? It's RF over RI. So this is the RI, the input. So as you lower this, the amplification goes up. This one, I don't know if it's not going low enough. I think I'll open up another game com that was sent to me and see what that resistance is, because I can always open this up and deox it, see if that helps, or swap out this potentiometer. I'm not too worried about this cap here, because that's just filtering out the DC offset, and that won't matter. But this cap over here, which is the final one, final filter cap, I'll probably pop that one out and see if that helps at all. Alright, here's another, here's an update on the game com repair. Some more light on this thing. So I ended up doing was going through and replacing several capacitors on the board. Bringing the magic microscope here. Actually, it's called the Mighty Scope. Take a look here. So, what got replaced was there's 4 caps in the audio system that I replaced. 3.3 microfarad, 100 microfarad, 10 microfarad, and I believe this one's a 220 down here. This one's the AC coupling capacitor before it hits the volume control. This one down here is the last cap it hits for before it goes to the speaker circuit, and these two are just part of the op-amp circuit. And then I also, you can see the wires now are not blue anymore. I replaced them with new wiring into the speaker. So let's see what she sounds like. So I've got my microphone pretty darn close to the speaker here. Outside of the housing, it's not a loudspeaker. I think they use the housing as a little bit of a reverb. Next up, I'll try to plug directly into the audio jack, but who knows. I also went through and did deoxit on this deoxit the potentiometer there. I've never seen it. This stuff is called deoxit. It's great for cleaning off contacts, and it leaves a nice conductive film on there too. So if you ever need to do like a repair to a cartridge, it's a great way to clean out the cartridge ports on these systems. So I don't know if I'm going to attempt anything more on this particular system, other than this. I might clean up some of the solder work down here on the audio jack and just plug it right into my computer's audio input to see what it looks like, sounds like. So other than that, there's not much more I can do with it. It's just the way the system on chip design is. There's no crackling anymore. It sounds a little clearer, so hopefully it helps. Okay, so I wanted to go over some of the more interesting economical choices on the Tiger Gamecom here. Going through the design isn't quite as horrible as you think it is. It's bad, but there's some interesting design choices. I think it was all driven by just keeping the cost down on the system itself. So if you really want to get some in-depth going here, I'm going to show you some parts of it. Alright, so back to our little Mighty Scope view here. Okay. Alright, at the heart of the system is, this is a Sharp system on chip underneath that. That black stuff is called Glop Top. It's a potting material they use in inexpensive electronics. Instead of having a discrete package, the package is nothing more than those ICs there. Those are in a package. But you can see here, this is just a glop top packaging. Under here, it's the actual processors. Under it's a system on chip. It integrates the audio controller, the LCD controller, memory access, all in one chip. What is external is, you can see here, there's the RAM chip, which is very crudely soldered on. And it's got to be pretty low capacity because there's actually not a lot of leads. Address, it's probably 8-bit RAM. I forget what it's quoted to be. It's quite low. And then you move up here. I'm pretty sure this is the controller chip for the modem. And over here, I'm not sure what these are. These might be double EEPROM, but I'm not entirely sure what those are. But you can see even with all these circuits here, they're very crudely, like, let me tilt it up, you can see they're kind of like just placed on top, and then someone would go through and just hand solder on all those solder joints. And there's my handiwork over there with new solder joints. And of course there's your 10 megahertz clock, quite low frequency. Now over here is where they really cut a lot of corners. I don't even want to point at it with anything sharp. But this here is actually the cable, the leads for the touch panel. And it's how it works is when it's actually down in place, this thing here is just a piece of compressible rubber. And when everything is placed on place, this whole board gets flopped over, and it holds down these this flex cable, and it's just literally just a piece of tape holding down the connector. You can see, I don't want to bend it back too far. I don't want to break it. But you can see it's just, you go from electrical to electrical connections, and it just gets sandwiched in between there. So that's very inexpensive design. And you move over to the LCD. This is the back side of the LCD. It's kind of hard to see in this shot, but this big, badly, I mean, this hot glue here is straight from the factory. And you can see there's just a lot of heat applied to the, these are all hand solder capacitors to solder the one side of the board. Just one little surface mount, a couple little surface mount components. Everything else has just been slapped on by hand. So it was designed to a cost, to keep the cost as low as possible. I will give it points for a couple things. The if you actually look at these are the pads they use for the controllers. The buttons, they all look like this. This is a nice thick what they call gold flash over copper. So you could tell it has to be gold because it hasn't tarnished over in the time this has been sitting around. So I'll give it that. The touch screen is just a regular, it's a resistive touch screen. You can tell by just the way the leads are on this thing. These are, that's what they call it. It's just the older technology was called resistive. Now, this might be capacitive. No, this can't be capacitive. It's just resistive. So you pressed on it, there's two plastic layers, and you can see the little dots there. It actually forms a grid, so when you press on it, it'll pick up that force. Of course, it's only a single touch. But my next goal is to see if I can actually separate out the reflective LCD layer from the LCD. Not on this unit, but on two less than perfect game comms that were sent to me to play with. So I'm going to see, once I get the electroluminescent layer in, I'll see if I can wedge in a layer and pick off a 3.3 volt source somewhere on this board. That'd be great, because then you can actually see if it actually makes it more visible or not. So, for now, probably is going to go ahead and put everything back together on here and see if I could actually see how it sounds once all put back together. Now it's just finding where all the darn screws went back to, and once it's put back together, I'll hook up the audio directly to my little workshop PC and see what it does. And I gotta just shorten up these leads again because I put these long leads on here just for testing purposes. But looks like it's almost done, and I got 2 more games came with the dead Gamecom, so I'll try those out as well.